All right. I think we're ready to start.
Yeah.
You want to start the recordings?
Yeah.
It's already done.
Yeah.
Already. Okay. Fantastic. Welcome, everybody. Welcome those who are here in the room and also those who are joining us online tonight. Thanks for coming out for this month's Azure User Group meeting. I'd like to thank everybody who came last month. How many were here last month? Oh, good. A few of you. Okay, great. So I was overseas at the time, so I missed the meeting, but I was at a Microsoft conference, so I have brought back a few stickers and stuff if anybody's interesting, and there's also some forms, well, for the Azure Connection program, if that appeals to you, feel free to take them. So normally Damien Berry does this part of the presentation, but he's unfortunately fell sick today, so he called on me a couple of hours ago to take his place. So just a reminder, we are, in addition to broadcasting this online, we are actually recording the event. And these microphones overhead that you see hanging from the ceiling are very sensitive. So they will pick you up. So your quiet conversations will become not so private, especially since we're recording. So just keep that in mind. The good thing about it is that when you ask questions, which I hope you all do, because it's a very interactive event, the question will be picked up on the mics, which is really good. Okay, so for those who come regularly to this event, you know that we start off each month with like a bit of just a 10-minute roundup of all the, not everything, but obviously some of the biggest things that have happened, because the cloud is always changing and moving. And we do a little bit of a summary just to introduce those topics so you're aware of them, kind of like, like a front page of a newspaper type thing. And we do want to thank our sponsors, because these events, they're free for you to attend, not free for us to put on. So we're very, very grateful to Microsoft for giving us a venue, this fantastic venue for us to present. And not only venue, but also the people who from Microsoft, like Bernie and Todd, who need to be here as our hosts, because we can't be here unless there's a host who stays after hours, and usually it goes on to like 8 o'clock at night sometimes. So session. So we really appreciate their time and their volunteering to do that. And then Codify has also given us a monthly stipend, and that covers the expenses like the pizza and beer that you're enjoying tonight. It also covers other expenses like the Meetup subscription and the Azure subscription that we have and stuff. So thank you very much to Codify and Microsoft. And of course, this is a community event, so we invite you to become, especially if you'd like to get up and talk about something. It's not as daunting as it sounds. You don't necessarily have to give a full 45-minute presentation, with 57 PowerPoint slides if you don't want to. Maybe you just want to get up for 10 minutes and talk about something interesting that you've done at your client and that your client will let you talk about. Or maybe just share something that you have of interest in Azure. And you'll probably find there are other people in this room, this community, who share that same interest, and we would love to hear what you have to say about it. So if you're interested in talking, please let us know. As you can see, we have a very, very full schedule for the year, so it's going to be very hard to fit you in. We do have some people of interest, but yes, we've got room for you. So don't feel like you have to take the whole night. We can do short ones as well. The talk I'm doing tonight is going to be pretty short, and I'm sharing that with Todd. Okay. And yes, and you can either email baug@outlook.com.au. That's your user group, obviously, or you can put something in the Meetup chat, or just approach one of us, and we'll be happy to talk about it. I know you said you had some ideas.
I suppose, I'll grab you at the end.
Talk to you offline. Yeah, excellent. Okay, so with that, we have the updates. Now, Damien Berry put together all these slides and information, but he was planning to be here to present it, but he got sick this afternoon, and I haven't even seen them. So what I'm going to do is send him over to Bernie, because he probably knows a lot more than I do. You said it for grab my.
Oh, so more updates. There we go. AKS. There's quite a few updates for AKS this month. So
host port auto assign. And so this basically gives you some like additional options to then link a pod to public IPs without having to have an additional load balancer. Instance level public IP tags, again, more like ability to then expose things externally. Pretty cool. Trusted launch. So what this is all about is launching virtual machines in the AKS cluster right from when they like initially power on all the way to when the operating system boots, and making sure that whole process is nice and secure. And so a few different features that are in there around VTPN, secure boot, and some additional protections as well. Again, just keeping everything nice and secure and trusted. Improved node limits. So prior to this, there was a small node limit that you could use for standard, and then there was a little high level SKU that you could obviously have more nodes. This has been updated so that then the standard also has some additional scale capacity that then it previously didn't. So again, you can have even more nodes in a single cluster than you could before. The Azure, the Kubernetes AI toolchain operator. So this is really about spinning up tools and services on top of Kubernetes. And then the cost analysis. So this is a good one in terms of really understanding within a large cluster, often tenanted by multiple applications and multiple teams, where the cost is going, who's consuming what within the cluster. So some pretty cool stuff with that. Windows GPU support. So GPU support within Linux-based nodes on AKS has been around for a while, but now this introduces the same support for Windows, or similar support for Windows. So now you can use GPUs. A lot of people using that for AI crunching and that type of stuff. Kubernetes 1.29 GA. Really great. Deployment safeguards. So this is cool. This is just really about if you've got an AKS cluster, now you can go ahead and turn on for the cluster to sort of say automatically require best practices. So when you go ahead and do your deployments and your developers build the different manifests for the different application or APIs that might run on the cluster, they don't necessarily always follow the same practices. And so here you can actually go ahead and turn it on to a validate, a warning and enforcement mode, which then actually requires that automatically by deploying some additional Azure policies on top of AKS. Application Gateway v2, IPv6 support. So Application Gateway v2 has been around for a while, and now it supports IPv6. Database filter. This is actually pretty cool. So, I mean, prior to this, a lot of organizations would have had experiences whereby deploying any database, either on premises or Azure, you typically needed to have some additional monitoring tools, particularly for measuring database performance. Now, for this currently only applies for Azure databases like Azure Database or basically the native PaaS services in Azure at the moment. It doesn't support SQL VMs yet, but this basically provides additional performance monitoring. So this is really about performance monitoring of SQL databases. And you can sort of see there, it's pretty cool in terms of the workbooks you get as a result. And you don't need to install any additional infrastructure. You just deploy the watcher and it will start collecting information. Database mirroring in Microsoft Fabric. So you may have been aware of Microsoft Fabric. We've been working with quite a few different customers that are interested in it. And this is sort of like a new look on how to move data around your environment. And now it supports database mirroring as well. Azure Static Web Apps, distributed functions. So again, this just provides some like additional capabilities. So static web apps normally have like a static web front end, so like HTML pages and JavaScript and things like that. And behind them, if you want to then start enabling APIs, you do that through a connection to Azure Functions. And now this provides some additional capabilities. Previously to this, the functions were only sort of in a single region, and they had some reasonable constraints around how they actually worked. This provides the additional capability to go across regions and things like that. So the agentless multi-disk crash consistent backups. What this is all about is that so previously a lot of backups were driven mostly by within a virtual machine. You would have an agent, and the agent would be a bit of software that would be installed on Windows or Linux, and that would go ahead and talk to the operating system and then make sure that it was safe to do a backup and things like that. That's good. However, that's software, and it has in it, because it's talking to the operating system, it typically has a bit of additional latency with how long it actually takes to do the backups and things like that. So now this actually provides an agentless way to do that under the covers. It provides crash consistent backups, which means that then there could be some transactions that are currently in the process being written to disk that won't be captured. But it definitely provides a nice way if you don't want to have that additional agent software, or you have an environment that then makes it hard for that software to be compatible. And for resources, again, these are the normal resources that Damien shows each month. So basically the Slack team, the YouTube channel, so all the previous sessions that we've recorded, I think, over the last few years are all there. So definitely check that out. Some blogs and also some related partners. And yeah, the Hanselman blog is really great. And tonight's presentation, our first one is Dan. Come on down.
Want me to go first?
Yeah, you go.
Okay.
Your picture's up.
Yeah.
It'll just confuse
people.
Yeah, so Dan Toomey is a Microsoft MVP, fresh back from Redmond after Summit. He's got a lot of things to tell us probably about that, but also he's a specialist in integration. You probably have seen him at quite a few roadshows from integration previously. And tonight he's going to talk to us about Copilot for Logic Apps, which I'm very excited for. So give Dan a warm welcome.
Todd should be Todd, I hope.
Todd, yes, I shall give you an intro too, if we can move to the next page. And what else? Here we go. Todd. Todd is a cloud solution architect at Microsoft. And again, he's got a lot of experience in all things app innovation. And so today he's going to give us a rundown in Chaos Engineering with Chaos Studio, which is an awesome service, and can't wait to hear more about that. Thank you.
Thank you, Bernie. Appreciate that. And the first thing is I may have forgotten to share the screen. Can you with the online people? I wonder if they can see it. Yeah, just see if the screen is visible.
Let's see a screen.
You can? Oh, okay. So that worked all right. Okay. But now I'm going to be changing slide decks. Let's see how that works. I'll let Kevin in. Just give me a second. Save changes. Save. That's fine. Second. Okay. Now, can we just check that they can see the screen on the Teams?
Yep. So like it's come up. Logic AI. Fantastic.
Okay, super. Okay. Well, thanks everybody. So this is going to be a very short presentation. I just wanted to kind of introduce a bit of a new feature that's in Logic Apps, but and the only thing I can say about the conference that I attended last month, because it was a Microsoft MVP event and everything that they told us is NDA. So I can't really talk about it in specifics, but I will be able to tell you, and it should be pretty obvious, is that AI is like a central thing to virtually everything across the board right now. So that's So that's probably giving those secrets away, I think. This is plain, I can say that. And Logic Apps is no different. So first, I think we just, for those of you who actually put your hands up, how many people have worked with Logic Apps before? Oh, a couple of you, but not everybody. So just my background, I'm an integration architect and I'm an integration specialist, and that's what I do. So this is the part of Azure that I live in, right? If you want to ask me about any of these services, it's fine. If you want to ask about anything else, ask these guys. Just to get you to understand where Logic App fits and everything, there are a group of services that we would typically use when we build integration services, integration solutions using the Azure stack. And one of the challenges that Microsoft had is that there are dedicated integration products out there. You know, you've got your MuleSoft, you've got the Toomey, you've got, you know, WebSphere. I mean, all kinds of things out there, and that package deliver integration in a box. And Microsoft's answer for the cloud-based integration was Azure. But as you all know, Azure, you know, looks it's huge, right? It's enormous. So we always had a challenge in selling that and marketing that. So a few years ago, Microsoft came up with Azure Integration Services, which is nothing more than a label placed on a collection of existing Azure services that you would typically use in integration. And you know, this logo and even the services that are listed change all the time. But the core ones are there. So you've got functions for just executing arbitrary code, obviously not specific to integration, but used in integration, as you would imagine. It's great for building those kind of microservices type of things in a serverless way. Data Factory is for doing ETL type stuff, so extract, transform, and load when you're moving heaps of data, like from one database to another. Messaging with Service Bus, I can't think of a single integration solution in Azure that we built that didn't involve Service Bus, because messaging is such a core part of integration solutions. Event Grid is for managing event-based notifications. So for that reactive kind of program that you have, when things happen, you want to respond to it. And of course, APIs are a big part of everything these days. That's what makes the digital world go around. So you need a gateway to manage that. And API management is Microsoft's product for being able to do that. And then last is Logic Apps, the subject of tonight. And Logic Apps basically gives you the ability to create workflows, persistent workflows that can do those long-running processes, and also be able to connect. It comes out of the box with a whole heap of connectors. Now, why did it disappear? Okay, there we go. So Logic Apps, yeah, as I mentioned, it's sometimes your integrations are a little bit more than just request response, right? You've got to manage things. You've got maybe you've got to send out to multiple consumers, or maybe you've got some kind of a validation that needs to be performed, you know, or an authorization step. So Logic Apps enables you to build these workflows. And one of the really powerful features of it is that it comes, I'll just do it like that, is it comes with all the connectives. Now that is grown. It's impossible to keep this slide up to date. It's probably the only part of Azure that's never going to be up to date. There are literally over 1,000 connectors right now that you can get and use with Logic Apps. So it would be a real challenge for you to come up with a software as a service product that isn't covered by a connector in Logic Apps. And of course, it also covers all of Azure's services as well for connected to that, and other Microsoft services like Office 365 and, you know, Outlook, all that kind of stuff. There are special connectors for doing B2B type applications as well when you're working in the EDI world. And then there's your standard protocol type connectors like SFTP, HTTP, so all those ones as well. So that's a lot of power there, because you don't actually have to code those interfaces. Those connectors are there for you to use, and you configure them in your applications. And basically, Logic Apps allows you to connect to everything. You can connect to any service in Azure, pretty much, as well as other Microsoft services. And you can easily, as well, reach into your on-prem solutions using an on-premises data gateway and connect to your main systems on that might be hosted within your own data centers. So workflows are created graphically. You can build them in the browser. You can also, with Logic Apps Standard, which we'll talk about in a moment, you can build them in Visual Studio Code as well. There's a designer to do that. And as I said, it's a workflow. So every workflow will have a trigger that starts it off. And that trigger could be a direct call from an HTTP call. It could be a scheduled trigger. It could be reacting to an event, like a file being created or a row updated in a database. There's all kinds of triggers. And then everything else that happens after that is considered an action of some sort. And that's basically how you build your workflows. So behind that graphical user interface is just JSON, and it's called workflow definition language. That's what describes what's actually happening and what gets deployed. So it's quite sophisticated. The constructs that it supports, it does everything that you would need a workflow-based process to do. It can run loops. It can have conditional statements. It has scope, so you can take a block of actions and wrap that in a scope to determine whether or not it's been successful or not, which is really helpful if you want to do error handling, because you can evaluate the states, what's occurred, and then have a conditional response depending on whether it succeeded or not. So it can do, pretty much most of your sophisticated integration patterns, enterprise integration patterns. So an example of how it might work is you create this workflow. When you save it, it saves it as a workflow definition. Just let somebody in. And you deploy that again. When it runs as a trigger task, which will kick it off. In this case, the trigger for this particular workflow is a service bus. Something arrives on a queue in a service bus. And then on that trigger, it then gets a new message. It kicks up a workflow orchestrator, and that workflow orchestrator is responsible for creating all of the tasks that represent the actions. So every action in this workflow becomes a separate task instance that executes. Now that's kind of interesting, because let's say that you have a loop, like in this case, this expects a message that has multiple line items and it wants to process through those line items. Normally, we would think, coming from code land, that the loop just executes sequentially, right? That for every row it'll kick off and then do it for the next row and the next row and the next row. But what actually Logic Apps does by default is that for every instance that's in that loop, it kicks up a parallel task, and they actually execute in parallel with each other. So that's something to be aware of, because that can have unexpected, results. If you're expecting things to happen in sequence or in an order, it won't necessarily happen in order. So you'll see this when I do my demo later. Now, if you want to override that, you can. So you can make it happen sequentially if you want, but by default, that's not what it does. So when that completes, then it's a task to complete the message in service bus, and the workflow finishes. And we're all good. So one of the things that Microsoft boasts about with Logic Apps is how resilient they are. As I say, these are designed to be long-running tasks. They're designed to do automated retries for transient type failures in it. It will handle that for you. So if this task goes belly up, okay, it will handle those transient failures and undo retries. The important thing to understand is that this is at least once guaranteed, not necessarily exactly once, right? So you have to kind of build your solutions with that in mind, that something might execute more than once. So you want to build item potency. There's a big word. Everybody know what item potency means? There you go. So the workflow definition language has a bunch of built-in functions that you can use, and you can script in your Logic App actions. So everything from string manipulation to calculations to logical things to conversions. There's an awful lot there, and that's probably not a comprehensive list anymore. And then I mentioned before, if you want to reach down into on-prem, you can use an on-prem data gateway, which is actually a very clever thing. It's service bus relay under the covers. It's what it is. And the thing about a relay is that the connection is open from an agent that lives on-prem on one of your machines on-prem, and it creates an outbound channel, but then establishes a relay point, a secured relay point in the cloud that your services can hit. And because of that, because it initiates as an outbound connection, you don't have the firewall issues, right? You don't have to open it, because most organizations will let you out on 443, right? But in it's a different matter. So, and then I mentioned Logic Apps Standard. So this is a more recent version of Logic Apps. We have two different models. We have Logic Apps Consumption, which was the traditional model. And then we got Logic Apps Standard, where they built it on the functions runtime rather than the consumption one, which is built on its own runtime, cloud-based runtime. And the advantage of Standard is that because it's built on functions runtime, you can now take it anywhere. You can containerize that. It means you can deploy them on-prem, whereas Logic Apps Consumption still is confined to the cloud. You can only run it in Azure. There's a few other key differences in there, but the Standard is generally the preferred way to go right now. And there is a Visual Studio Code and designer for that you can build, whereas Logic Apps Consumption, I think you still have to build the workflows in a portal. Integration account is a very specialized thing. If you're doing EDI, for example, where you have to manage things like trading partners and agreements and things like that, you need a place to store that. The integration account is what's used for Logic Apps Consumption in order to store that stuff. And they also store schemas and maps and things like that. With Logic Apps Standard, if you're just needing schemas and maps, you can actually do that within Logic Apps Standard without an integration account, which is good because these accounts are not cheap, actually, to run. So all that long-winded intro into what Logic Apps is and what its place is in Azure as far as integration solutions. So what is relatively recent and has to do with AI is that they have built in a workflow assistant. So now, and it's currently in preview, but if you go into the portal and you go to the designer to build a Logic app, you have this assistant feature, and that gives you sort of Copilot like type capability in there. It's built on Azure AI, which is good. So at this point, I think I'll just show it to you rather than talk about it. Except that you won't see that unless I do this. Hang on. Duplicate. Okay. Bernie, can you check if that's is it browser showing on? It is? Okay, fantastic. I want to make sure it's doing. Okay, so what do I have here? I've got an app service plan here, which I'm using to build Logic apps. You see, I have one already, but I'll go ahead and I'll add a new one, and we'll build one from scratch. So I'll give this workflow a name. So I'll say LA CP demo. Okay, and we'll make this. Oh yes, another thing that Logic Apps Standard does is it introduced the ability to have a stateless option. So consumption Logic apps are always stateful, which means it persists the state. And generally, if you're going to have a long-running processor, you want that. But sometimes maybe you just want to use Logic apps to orchestrate connections that are real time, and you don't need to persist state. If you go with the stateless option, it performs a little bit better because it doesn't have to do all the persistence, right? So it gives you that option. We'll just go with the stateful for this one. Okay, and I'll go create. And I have that now. So if I open this up, I'll go into this page where I have the option to choose either the code or the designer. As a developer, I'll do the designer because I don't feel like writing JSON by hand. And you can see that the very first thing it asks me to do is to add a trigger because every Logic app has to start with a trigger. But what's kind of cool is that you got this assistant here. So now I can use a chat interface here to ask it, how do I build an application and tell me how I can use this in Logic Apps. So let's say, how do I receive a list of customers in JSON and store each record in Azure Table Storage? Okay, so I'm going to ask it a question and see if it can tell me how I'm going to do that. So it's working. And can you read that, by the way, or is it too small?
It's okay for the front row.
Okay for the front row. Hopefully okay for the people online. Okay, so what it's done is basically given me the steps here that I have to do. So it says create a logic app in the Azure portal. Yep, okay, well, that's where we are. Add a trigger to your logic app that retrieves a list of customers in JSON format. This trigger can be an HTTP request, an API call, or any other method that provides the JSON data. So it's up to me to decide how I'm going to receive that data. It's going to add a for each loop to iterate over each customer record, and inside the loop, add an action to store each customer record in Azure Table Storage. That seems pretty obvious. I'm probably going to need a little bit more detail as I go into it, but let's get started and see how well it can teach me how to do this. So first thing I know I have to do is add a trigger. So it says here I can receive the trigger as an HTTP request, which is fine. So I'm just going to do HTTP. Right, that's what I want. And I've got right here, I can see when an HTTP request is received. So I can go ahead and choose that action. When I do that, I'm going to be able to configure this. And one of the things I want to figure is what the method is. So the method in this case is going to be post, because that's how I'm going to do it. And I think that's probably all I need to configure in this. Now, I can tell it what I expect what that is meant to look like. So I can put in a schema there that describes what my message, and it'll validate that and know how to handle it. Let's try that. So I've got a schema here. Back to MVP. In here, I've got a schema here. I will copy. Okay, use a sample payload. No, I just put the schema in there. Didn't need a sample payload. And that configures that shape. Oop, invalid parameters. What's wrong? Enter a valid. Oh,
Miss
did I miss the last curly bracket? There we go. All right. Okay, cool. This is a save. There we go. All right, there. So it's happy with that. Okay. Add a trigger and any other than request shape. Fine. Now add a for each loop to iterate over each customer record. So I'm going to add an action. And for that, I'm going to call a for each. There we are. For each loop. Okay. And now this is interesting. If I go into settings, it says concurrency control. By default, Logic Apps instances run at the same time or in parallel. Remember I was saying how in a loop, it's going to do everything. I can change that if I want to. I'll just leave it here for the moment with that. And then inside that for each loop, I need to add an action to store customer record in table storage. You can use the insert entity action. So I'll add an action here. Let's get out of there for a moment. Add an action. And we will do, what's it called now? Insert entity. Azure Table Storage. That's what we want. Okay. Now, I have to configure this to connect to my Azure storage with that. So I'm going to add an Azure account name or endpoint. Now, because I've already configured a logic app to do this, I have a connector already for it. So I won't take you through the whole process of creating that, but normally we'll just get the connection string and configure that, and then that connector would become part of the solution. So I'm just going to say use that, and then specify the table. There is a customers table that I have in there. If you want to see it, by the way, here it is. Here's my storage account, and there is a customers table, and you can see I've actually got some data in it. So I'm actually going to get rid of that data so that we have a clean table to start with. We call that. Okay, go back in here. All right. And then the entity to insert. Now the entity must contain the entities for a part. Yeah, you can't read that, can you? There's more. Oh, there it is. So when you're creating an entity, the two things that are absolutely required are a partition key and a row key for it. Those are mandatory. Anything else that you want can follow that. So again, I have a bit of a schema for that, for what I want to do. So I'm going to copy this, put that in here. And now what I have to do is give it the values. So the values should be able to come from data that we have in the previous step. And you can see, because I've outlined what the schema is going to look like in that request, I get these prompts here for the actual fields in that message. So I can just choose them. Everybody follow that? Because I gave the schema in the request, it's actually pulling that definition from the HTTP request received. So partition key. So for partition, I'm going to use, I think I'd use, yeah, I use state. So I just basically put my cursor where I want and select that field, and I'm actually dynamically able to add these items. And the row key will be the ID, because I'm expecting that to be unique. The name will be the name. The age will be, now the age is not a string, it's a number, so I don't need to put it in quotes. Sorry, it's a little bit slow. Age. Here we go. Age. Sex, I'll put that in there. That's not a yes, no question. And email. Here we go. Oh, come on. I'm being a little bit. What was that going to be? Sorry, email. There it is. Email. Okay, so now I've identified that, and I've said to insert that HT. Okay, so basically that's all well and good. Now the only problem is, well, that's all right. No, we'll leave it. So I basically have done what it's told me to do, right? So I can now save this logic app, and when I save it, okay, validating, error validating workflow parameters. Okay, what doesn't it like? So something it wasn't correct. Invalid parameters. Ah, yes, that's right. Select an output from previous steps. So, I know I have to tell it what it's going, yeah, what the loop is looping on. It's looping on customers, right? Because that's the array that's in that message. There we go. Now I should be able to save it. Yes. Okay. Now, if I want to execute this workflow, what I need to know is what the URL is. So it says the URL will be generated after save. So I'll go ahead and copy the URL, and I'll go to my friendly postman. Okay, we'll have, that's the one for my old one. So we'll go ahead and create a new request. It's going to be a post operation, and I'll paste my URL. And when I do that, you'll see, oh, it didn't copy the URL.
I don't think it actually generated the URL twice.
It didn't, but it should though, because I have saved it.
Showing. Just gonna refresh your.
Maybe jump out of the designer and back in.
Yep, I think I'll do that.
Like refresh all the time.
I don't know.
Yeah, that's right. Turn it on and off. Okay. Yeah, and then if I go into designer now. A little bit slow. There we go. Now we have a URL. So we can copy that. All right, and paste it in here. And this should work. Now you'll see that the URL is a query string, which includes a few things. There's an API version, obviously. There's an SP for it and a version. So a workflow process, basically a name for it. And there's also a shared access signature. So that's how it does its security by default. So I go ahead and execute this. We'll see what we get back. All right, so it says 202 accepted. And if that's actually worked, then when I go back to my table storage, refresh, no items found. Interesting. Okay, so what went wrong? Well, what I can do is I can go in here, go close the workflow, go back into the overview screen, and the overview screen will show me that there was an instance that was run, but it failed. I can go in there and then look and see what's happened and what I've done wrong. So you can see that in the for each loop, it failed. If I go in there and see the execution for each failed, the result of the evaluation for each is customers is of type null. The result must be a valid array. I know why.
Body.
I didn't put a body in the message. I forgot a step. So that's actually, well, at least you see how you debug now in Logic S, which is pretty cool. Yep, sorry, let me go and grab the body of the message, which is this. This was supposed to go on the request. Okay, so whoops, not everything. Sorry, I'm not very good at using a trackpad, as you can tell. Copy. And thank you for your patience. We now go into the body and we'll put body. But interesting how the workflow returned a 202. Sorry, raw. Call it JSON. So that's what it's going to be. And paste it in there. Okay, so now when I send this message, it says 202 accepted. And hopefully there'll be some data in this table. So we'll refresh. Look at that. There we go. My 4 records were created. So Copilot basically told me how to set this up, right? And do it. Now I could get a little bit more fancy. I don't want to spend too much time and rob Todd of his excellent presentation. But if I wanted to ask it, because if I wanted to ask it specifically something, how to do something like if I, for example, said, how do I loop through, oh gosh, I can't type, through the customers sequentially? And see if we can come back and answer that. I spelled it wrong, but hopefully it knows what I'm asking.
It's pretty good at that.
It is pretty good at.
Well, I don't know about that one, but other ones, they can make sense of it.
Okay, so it says I should use the for each action in the provided workflow. There are 2 for each actions nested within each other. The outer for each action iterates over the customer's array, while the inner one iterates over the customer's array and the trigger outputs. Within the inner for each action, you can perform actions on each customer item, such as inserting an action. I don't think it got my question quite right, because that's not right. So obviously, let me ask this again. How do I ensure the loop executes sequentially?
I think that you miss the B loop.
And use the what, sorry?
I think that you miss the B in the word loop.
Oh,
So if you don't understand.
oh, okay.
It's 3 times O.
Oh, right. I see. Setting the sequential property to true, each iteration of the loop will wait for the previous iteration to complete before starting. Well, let's see if that's true. If I go into the for each loop, okay, and look in settings, where's the sequential property? Oops. So this is probably what probably happened here is that the document, that an older version of Logic Apps probably had that property, and it's taking it from documentation from somewhere, or it's hallucinating, one or the other. But that's one of the things you have to be careful of, right? So there is actually a way to do it. You can turn a limit on, and then the degree of parallelism, I can bring that down to 1, and then it will only execute 1 at a time. If I wanted to do it that way. I could ask it a question of how do I make this Logic app more resilient? Be interesting to see what it says about that. Thinking. Okay, so use retries. Gives me a lot of general information here, like using scope, which I talked about before, where you can wrap things in a scope, using retries, using a backoff strategy, monitoring and alerting. So lots of interesting. The other cool thing you can do is I can say, describe this workflow. So because it's context aware, right? It knows I'm talking about this particular Logic app. I can actually ask it to do that, and we'll see if it comes up with it and tells me what it actually does. This workflow is triggered by an HTTP request and has a single action called for each. The for each iterates over the customer's array in the trigger body. Within the for each action, there is another nested for each one. No, there is. Oh, yes, there is. Oh, I actually built it that way. Did I actually build it like that? Okay, I didn't even notice I'd done that. All right, so that's why it's doing that. Okay, so that makes a post request. So, but it actually has pretty accurately described what the workflow is doing. So you can see that there's some value here in terms of documenting a solution, for example.
And most workflows are that simple, right?
Right.
So,
Well,
having somebody describe it might be quite helpful, because a lot of workflows that I've seen, and I'm sure a lot of workflows that Dan's built over the time or had to deal with, they're generally not 2 actions, right? They're normally like 20, 30, 50 actions.
Let's show you this workflow. This is the one that I initially built when I was putting it. So this one's a little bit more complicated. It does the same thing functionally, but you can see that I've approached it slightly differently. Instead of using a schema, for example, in here, I actually used a parse JSON shape to break it down into its elements. It does the same thing. I then did put in a scope, and I actually did some error handlings in this. So this workflow, and I'll show you what the difference is. If I go back to this workflow, this is for that other one and execute it. It's going to fail, and it's going to fail because the data is already in the table. So you can't have multiple keys with the same, right? So that's going to fail, but it's actually going to come back with an error. So it error saving customer forward to table storage, because it can't insert customer forward because it already exists in the table. But now if I go back to that workflow and do the assistant here and say, describe this workflow, it's a little bit more challenging. We'll see if it gets it right. Okay. Yeah, so actually now it is talking about, it's quite involved actually what it does, and it describes the fact that it's parsing the array, that if it's successful, it continues the process. If it's not successful, it'll throw an error. There is a set variable that sets the current customer ID, because I captured that so I can output it in the error message, like you saw, customer 4. Yeah, so it actually does a pretty good job.
Seeing examples of these with other chats, not so much with Logic Apps. Can you ask the question something like, please review the current workflow and suggest improvements in performance and error handling, and see what it comes up with?
Probably can. So remember the last one I said how do I make this more resilient? And it came out with like 5 or 6 different things, and not all of it was actually code. Some of it was about monitoring, and some of it was about So, yes.
Yeah, I also saw that you have the ID predefined, the ID for each customer.
Oh, how I define the ID.
They are predefined, so they're given the values. So if we assume their primary key, is it possible to just send the data without ID and the logic hub just randomly assign the ID?
So what you're asking is, would the logic app be able to assign a unique ID?
Yes.
If I wrote it that way, yes.
Okay.
I didn't, because it's a very simple example. And for this example, I'm assuming that the ID that passes in with each record is going to be unique.
Okay.
It was just basically to demonstrate the Copilot. So I won't take up any more time, but there's something there to play around. Oh, sorry.
Very quick question. Is there any future scope for this workflow assistant where it's actually going to help you build it? Like you can type a prompt and then it will build it for you rather than tell you how to build it?
So will it generate the code,
Yes.
basically, is what you're asking it to do?
And help step out of the flow.
You know, I doubt it will do it in the portal. I could.
Power
Right.
Automate already does that.
What does
Power
Power?
Automate, the Power Automate, if you are, telling I need this,
Yeah.
it actually builds the code.
So,
It doesn't mean that it's gonna be 100% good,
Yes.
but it's very similar.
so assuming at some point that might be a thing here.
Most definitely it's in the pipeline of Microsoft.
I wonder if I built this in JSON instead of the designer, whether it would autocomplete the JSON code. I don't know. So we can-
I'd like to understand, I mean, it would be awesome if it automatically builds the workflow. I'm not entirely sure whether that's the intent. They are planning to add more features to it though, so I guess I'm not aware of any feature there, but I would suspect that then the first point that you'll see that will probably be GitHub Copilot, because GitHub Copilot in VS Code has a lot of integration with extensions, so it would probably be something that will happen probably reasonably soon, I would expect. But if it's going to happen in the portal, who knows? I don't know anything about that at this point.
Yeah, so this is in preview, so we're going to see it probably evolve a little bit as Copilot evolves throughout the
Yeah.
whole
It
all
definitely
of
be
Azure.
Sure.
Okay, I just wanted to also mention one other thing, and I won't demonstrate it or go into it tonight because I haven't actually had the chance to play with this, but you're also able to use Logic Apps to build OpenAI applications, intelligent applications. And what it does is it helps simplify the back-end management, because there's a number of different tasks that you have to do when you're creating one of these things. For example, you might have an ingestion workflow that does your data acquisition, and then it has to tokenize that data, and then it has to embed, do embeddings generation, which is how OpenAI works, and then index all of that stuff for you. So you can actually do that in a workflow because it actually comes with some pre-built connectors for Azure OpenAI and Azure AI Search. And then you could have another workflow that's your chat workflow, which would basically go through and prompt, a capture, then model the training, and then generate queries, and have an embedded conversation that you could to interrogate that document and answer questions about it. So this is also coming into development right now, which is pretty cool. Actually, you can use Logic Apps to build AI solutions.
You build like templates for the workflows to automate the process, make it faster.
I think there are Logic App templates available. I don't know if they have one yet for this, but they probably will soon. I imagine as this evolves. So yeah, if you go in to create a Logic App, you can have it create a predefined template for you, which one way to help automating your build, right?
Yeah.
So that's something to look out for. There's a few resources here. I will pop these slides up somewhere and put the link in the chat, along with the deck with the Azure News Roundup as well. That'll also go. So look for that within the next couple of days. And with that, I'll end my presentation. So. All right, now you're going to use your laptop, right?
Yeah.
Okay, so go ahead and move this out.
Sharing your screen.
Am I still in Teams?
Looks like you can see that online.
Oh, good. Lots of monitors. There we go. Perfect. All right. Now, Dan has generously acquired in Redmond a couple of very interesting little swag items. One being a
I'll take it.
Microsoft Reactor. No, it's not that easy.
Oh.
Microsoft Photo no. And a slightly epileptic sick fidget spinner. So if I get some good questions, I'll put them up here first. People,
Would you like $100?
that's a very good question.
Would you like Saturday night's winning lotto number?
That would also be handy. Next Saturday, I should be more specific. Next Saturday. Yeah, it's not last Saturday. Awesome. So thank you very much. So what I'm going to talk about tonight is creating chaos in Azure on purpose, because it's super easy to create by accident. You just hire developers. And I kind of think of that, that old joke about, some people have, everyone has a testing system. Some people are lucky enough that it's not production. Well, Chaos Studio is a little bit the same, right? So some people have chaos testing environments. If you're lucky, it's not your production system. Because we all have chaos engineers, they're called users. They'll do the unexpected and when the system does unexpected things. So what we're going to talk about is a little bit about, why does this matter? Why is this so hard to make apps reliable? We'll look at chaos engineering, very quick 10-minute overview, and then we'll dive into Studio. And I just thought it was kind of appropriate and a little bit meta that when I asked ChatGPT to give me an image of Clippy trying to say, it looks like you're trying to build reliable software, it couldn't get it right. So it's kind of symbolic, I think, of, software goes wrong when you least want it to expect it. So when we think about building any kind of any kind of good quality, high quality app in Azure, in Microsoft, we talk about our well-architected framework with these 5 key pillars, and reliability is one of those pillars. I kind of highlighted there how you achieve that, right? And there's a whole lot of things, but I did like these kind of things. First of all, what are your requirements for it? What do we, my version of reliability for my blog is very different from a financial institution or a government, providing key services version of reliability. And it doesn't just mean 100% uptime. It's like things will go wrong. What do you do? Which are the key parts of your processes in your business that actually matter? And how do you want to handle those? Because just having it running all the time may not be an option. If some critical part's missing, maybe it's got to do some kind of alternate behavior. So how we do that, one of the key things there, list calls out, we want to test it, of course. Any testers in the room? Yes, I'm looking at you. But how do we do that? We're good at unit tests, performance tests, loading tests, but how do we actually test reliability? We certainly architect for it, putting on my architect hat. We know about things. Yes, the database might go away, this might go away, and we design it in such a way that we think it will work. But will it? And that's kind of what reliability is all about. It's actually putting that to the test. But not only that, thinking about, hey, when it does go wrong, do we actually monitor? Does it show up that it went wrong in a useful way in our monitoring and our alerting? Do our processes respond to it appropriately? Spoiler, not usually. So the other key thing is that, like everything in Azure, right? It's a shared responsibility. So Microsoft has the job of building, building and running the underlying foundations, the core infrastructure that Azure sits on, but then also the services that that we provide to use to make sure they themselves are built in a resilient way. But then critically on top of that, we then need to provide resiliency features for you to use so you can make your apps or your environment resilient. But then as a developer, as an architect, it's your responsibility to actually know what they are and how to put them together and how to use them. So there's kind of both at 2 levels, both in terms of your app itself, but also turning on the things in Azure that will help make you resilient. Right. So that's everything from big picture things like you can think of availability zones and running in multi regions and all that, through to understanding in the different types of redundant storage and the different kind of failovers and all those kind of good things. Oh, there we go. It's got words. Okay, so chaos engineering really is the way to do that testing, right? It's that way to, in theory, we think the system's going to behave this way when a certain failure or group of failures happen. But we want to prove it. We want to do it. So it's not just, although it could be fun, it's not just randomly turning things on or off to see what happens. I mean, you could certainly do that, and that might not be a bad kind of red team exercise. But the idea here is we want to make this an iterative process. We want to come up with a hypothesis, because we need to understand how we want it to behave before we can actually test to see if it is behaving. So we might say, hey, we've rewritten our app so that if it can't write to the database, it will send a nice message off to the user and it will write it to a blob storage queue and process it later. That's how we might think it's going to happen. That's our hypothesis. So then we need to design an experiment to test that. We need to come up with a way that, okay, well, let's find out a way to make the database fail so that we can see if that's what actually happened. That's when we analyze the results and go, well, to do what it was going to do. And then we can improve our code or improve our process or whatever it is, and we can keep improving. So chaos engineering, well, that sounds really cool in terms of chaos. It's not a one and done, right? The idea here is like all good testing, right? Like load testing, like all sorts, UI testing. We want to kind of move away from that thing where it's a deployment project on our go live date. Have you done load testing? Yes. To being something much more iterative. How do we build into our pipelines? Might be on a nightly build or a weekly build or a release build or something like that. You know, how do we actually build in so that we, before every single release, we do load testing, we do chaos testing, we do UI testing. And where it really gets interesting is when you start to combine them. Like how does our app respond to chaos or faults under normal load? It might respond quite differently under high load and vice versa. So we want to sort of start to think about all those things. So like, well, I used to be able to say this, I can't say this anymore. I used to say most good things that came out of Netflix, right? That's where this came from. It's been a little bit shaky over the last few years. But so they developed this tool called Chaos Monkey. Because literally when the Netflix exploded and they moved all their environment into the cloud, they were having all sorts of issues tracking down problems and not understanding how their code would respond. So they created this in Chaos Monkey, which is open source. You can still download it. But it's actually relatively simple what it does. It literally goes in and turns off VMs or containers randomly or according to certain parameters. So that's kind of the extent of what it does, turn stuff on and off. So it really is that literally chaos thing. And they got very, very sophisticated with it in terms of their process and their culture to the point where this thing was running in production. Right? So this would just routinely run in their production environment without any great concern or drama. So I don't know about you, how many would like your apps to be randomly turned on and off? I think we're still struggling to build the confidence to, you know, deploy an application at 5 p.m. on a Friday or the night before Christmas. You know, when I walk into customers and they tell me how long the change freeze is at Christmas, that kind of gives me a bit of an indication of where they're at in terms of maturity, right? So this is kind of one extreme, and it's certainly not appropriate for all. So, but there's other tools to do chaos testing, right? So there's Chaos Monkey, which is that simple one. I did find this one, which was kind of nice. So what this one does, this is for a Kubernetes workload. It's going to start. There we go. What it does, it reaches into your Kubernetes cluster, pulls out the pods. So the pigs represent pods. The cows are deployments. And you can run around this environment, randomly kill them, and that will run off and kill the equivalent thing in your Kubernetes. Kind of fun. But, you know, I think something more appropriate to be something like Cube Doom, which does the same thing, but does it in Doom, because, you know, retro games are definitely cooler. So each of those monsters is a pod, and every time you kill one, you can see it's killing off a pod in the cluster. So again, that's great for that really random kind of testing. But it's probably a little hard to justify playing it too long. So maybe we should use Azure Chaos Studio, right? Because that's effectively what it is. The idea of Azure Chaos Studio, fully managed service to orchestrate and define what those experiments are, and provide a library of injecting faults into a running environment. And it's really handy. As I've kind of really started to learn up about this, one of the challenges is, you know, we don't tend to run, you know, your app environment tends to have a lot of different things in it. It might be an app service, it might be a Kubernetes cluster, there might be Linux VMs, there might be Windows VMs, and all these things have tools to do this stuff. And they're all completely different, right? So one of the great things about Chaos Studio is provides that kind of unified way. You tell it what you want it to do. For example, trigger a DNS failure or increase load or simulate, I shouldn't say simulate because it actually does it, but, generate load on memory or VM or on storage or whatever it happens to be. And if it's a Windows machine, it knows how to do that and installs it. If it's a Linux machine, it knows how to do that. In the Kubernetes land, it uses Chaos Mesh, which is an open source Kubernetes sort of product. So there's all these different tooling, and rather than having to go out and learn them all individually, you can use Chaos Studio to orchestrate it. And the other thing is it integrates very nicely with a couple of other Azure services. We'll have a look at this in action. Things like Azure load testing, Playwright for UI testing, all these kind of things. Individually, they're great, but they work really well together. So there's kind of 4 disruption types or fault types we want to think about. So on the extreme right, there is stuff that's built into Azure that Microsoft internally uses to test the stuff. If you remember the bottom row of that pyramid, the stuff Microsoft look after, they have Chaos for infrastructure. We use that to test that. And there's a great story of, I think it was the Key Vault team, which is kind of a run. Like they decided to do a bit of Chaos testing for their project because they were rolling out, this is where Key Vault was rolling out, and they were super confident in their scaling and they'd built all this great stuff and they'd tested all these things. When they put it all together and ran it through Chaos Studio, they found out that actually one of the rules cancelled out the other rule, so it did 0 scaling and it died within the first minute. So much better to know that before you actually deploy it. So we do all sorts of things internally. So really the main 2 things we're going to look at tonight are the middle 2. So there's agent-based faults. So literally on the VM or on the container or whatever, there's actually an agent that's installed to do things. So that might be, as I said, generate load that floods the CPU, the memory, all those kind of things. So it actually operates on the thing. But the other is the direct ones, the service direct, right? So that's where we can actually talk to an Azure service to do something. So for example, we'll see in a sec for Key Vault, we can expire a key or deny access to a key, and it actually does. Chaos Studio does that by talking to the Key Vault service. It knows how to create those scenarios, so you don't have to do it. So it's kind of those very 2 different types of thing. The third thing, which is probably which is where a lot of the work coming out shortly in Chaos Studio is about, what about within your actual application code? How do we also bring that into the story? And there are previews at the moment for the Azure SDKs that help do that and surface that into Chaos Studio, but that's sort of the next big area. Put all that together, what it allows us to do is quite a rich set of failures. So everything that you would think of, turning on CPUs on or off and things like that, but through to even some really nasty things like, hey, what if you lost access to Microsoft Entra for 30 seconds, for a minute, for an hour? What would that do to your app? Now, it doesn't do that by actually taking out Microsoft Entra because people will probably get quite upset. So it actually does some sneaky stuff behind the scenes and add some firewall rules so you can't access. So things like that. But you can imagine. But some really interesting things too, because it's not always just about failure, right? It's about that brownout period. How does our system respond as CPU pressure starts to increase at the same time disk is going off? And I know that because I completely managed to get my AKS cluster into a state because I'd accidentally deployed a very, very small instance. So it had no headroom. So it couldn't actually, it was trying to do all the smart things and back off, and it just did not have the headroom to do it. That was an interesting thing. But and then especially when you get to things like Kubernetes, there's all those abstractions that exist within Kubernetes, the same sort of thing. Hey, how do we introduce DNS failures at a Kubernetes level, not at your overall level? How do we stop pods talking to each other that we assume they can talk to each other, all those kind of things. So it starts to get very, very interesting. So the way the heart of Chaos Studio is these experiments. And they're good in that you can create multiple steps, and each step can have a branch. So the steps run sequentially, 1, step 2, step 3, but within each step, you can run these branches in parallel. So it might be things like, hey, go and put CPU pressure on, go and upgrade the CPU to 95%. And I found it was actually interesting not to like fully flood things, but get them in that really annoying point where things get into deadlocks and they think they can keep going, so they don't trigger their recovery process, but they really can't keep going. So, and you can have as many of those as you like going through. The other really cool thing, which I've only just started to touch on, is selectors. So in terms of these steps, which resources are we going to apply that to? So at a simplistic level, you can go and say this cluster, this node, this pod. So it's sort of effectively hardwired what it is. But you can also use the Custo query language, so KQL, to make those dynamics. So you might go through and go, hey, I want you to apply this to all the pods in my cluster that have this tag and are on this namespace and have a memory requirement greater than this. Or I might say, hey, I want you to go into all the VMs I'm running that are in AZ1, turn them all off. So you could do some targeted AZ type stuff. So anything you can write a query to, which is pretty much anything, then you can make that very, very dynamic. Cool. Oh, that's what I was going to show you. There's a little example of a very simple one, but a Custo query where it's a virtual machine and it's in East US. Those Custo queries, and that's something that I'm really loving Copilot helping me with at the moment. That's one of the other, I don't know. Custo went simple stuff because it looks like SQL, looks great, but as it gets more complex, it gets a little bit less fun. The Copilot for that has been. So what we're going to look at is a bit of a more complex environment, right? Because this is super easy to do on one VM or a small VM or all those kind of things. So this is actually, I found the Chaos Studio team have put out. It's on GitHub. It's called Contoso Traders, because you know Contoso for the win. But what I like about this, if you look at the environment, it's got almost everything. I shouldn't say that. But in terms of app hosting platforms, it's got most of them in there, right? So we've got, in fact, I even boxes. Look at that. I went all out. And the core bits we're going to test here, particularly, are an AKS cluster, which is serving our products API. And then also we're going to do key vaults, just because it's not an app platform, but it sort of shows that service. So what this app is, this is your normal e-commerce website. We're in the AKS cluster, we have our product info, so that's where we're going to go to find out about one of the products. We've got a web app, which is, we've got a container app, which is storing a shopping cart on our website. We've got some other bits and pieces. So although I'm going to show you tonight, just because the demo is quite simple, you can use this as a good kind of test bed to start building out what you'd like to do. So I thought, given these things take a little while to run, I'll just grab some screenshots. So here's the super exciting, amazing e-commerce site. So when it pulls up this product information, that information is coming from hitting our product API, which is running in AKS. That's all it's going to do. So the good thing, well.
Just a question from the audience.
Yes.
Does it mean chaos engineering requires more financial resource to provision those testing environments?
It would. It's probably like anything, right? It would depend on where you're doing it. So if you have static, like dev, test, UAT environments, and you're still using those, then you don't need to provision new resources. But obviously, running things hot and testing would do. But the other part is, and I'll show an example later. If it becomes part of your deployment pipeline or a nightly build, then you would run the resources for that time. But like that environment, in this example, it's all provisioned dynamically from a repo, so you wouldn't necessarily need to run it very long. But yes, absolutely, there would be like, I'd think of it like load testing, right? It's a thing. There's an expense going to be there. It's the value of it that makes it useful. Hope that helps. Now this is important too, because by default you can't run Chaos Studio against stuff, right? If you try to just go in and set up an experiment, you won't have permission to do anything, because by default there's a separate permission in Azure to allow it to be included. So you need someone with the right permission. You need to come in and say this resource, this resource, this resource, right? So for example, you probably don't want to do that in production until you're really ready to do load testing. So by default, it's a blacklist. You need to whitelist resources into it. So in this particular case, did I do boxes? Oh, I did boxes. Look at that. Okay, so here is our Key Vault resource. So you can see there we've got both those service direct and agent-based columns, those two different types. It's the service direct is enabled for Key Vault. I didn't do the other box. For our AKS cluster, the service direct is enabled for there. Because again, for this one, even though there's VMs under the hood, we're actually going to interact with AKS to do this, not the actual VMs. You could do the VMs, but we're not going to do that for this one. Because this way it knows about Kubernetes abstractions. Right? If I go and have a look at my Key Vault, here's the things I can do. Because each service has a different set of available services, depending obviously what it is. So in our case, what we're going to do is actually just revoke their Key Vault access. But we can go and do things like disable a particular certificate, increment a certificate version number, like how many system outages are caused by certificate issues, because we know if it's not DNS, it's certificates, those kind of scenarios. So that's what we're going to use. For the Kubernetes one, I get very different options, right? So as I said, we're using an open source project called Chaos Mesh, which kind of has these different classes of failures. You can see there, even I like the mesh kernel. The time one is interesting. So one of the interesting problems you get at certain times of the year, that's kind of ironic, is, what about when you cut over to daylight savings, time moves forward an hour, moves back an hour? What does that have on your app? Leap years, all that kind of testing, which is really annoying to do. All of a sudden you can start doing that. Or maybe it's you're moving a workload from region A to part of the world to region B. It's a whole lot of really interesting things. And then within each of the, and then if we're not doing it, but if we were doing kind of VM-based things, you can see kind of a list here, right? So it's everything from killing off a specific process, maybe that's running on that VM, through to disconnecting a network, introducing network latency, which is kind of interesting. So again, not just turning things on or off, but how does it behave when things start to get slow and choppy and all this kind of, and again, time change, all that kind of stuff. So really interesting. So for AKS, once I've enabled that service, it runs off and deploys the chaos testing, the chaos mesh and the controllers. So it actually creates, I may have even created, so I do that. So there's chaos testing components that actually live inside the cluster, get their own namespace, and they get deployed in there. So they're not going to, they're not running directly beside your application workloads. But we can drill in there and we can see there's controllers, there's even a little dashboard and things, and a chaos DNS server, because it does some DNS jiggery-pokery along the way that really messes with Kubernetes, and then multiple pods and all that kind of good stuff. So that's great. So we've got it enabled in the service. We've got Key Vault and AKS involved. We've got our app deployed. Now we need to define one of those experiments we spoke about. So there's two here. One with the KV, that's the Key Vault one, and one, the AKS one, which is, these are pretty, another box. They're pretty straightforward. These are just one-step things. But here's our simple one, step one, branch one, and we've just introduced an action there called Key Vault deny access. And we're going to do that for 5 minutes, and we've told it what resources we want. Yes, which in our case is just that one Key Vault. But as I said, instead we could make that dynamic, use the KQL query to maybe pick a range or pick a location, or things like Azure tags. So maybe Key Vaults, you got some Key Vaults for certificates and some Key Vaults for whatever. You can just narrow it down, those things. But that's all that test is going to do for 5 minutes. Now, this is a little snippet of the code that's running our products API. And the way it's built, if you have a look in the middle here, this is the dependency injection. So when this API basically starts up, it runs out to Key Vault and pulls in the keys it needs to go and do its stuff, right? I don't even know what it is. I think it's some kind of managed identity. I think it talks to a SQL database and blob storage. So, but it only gets those keys at startup. Okay, so that's how our code's written. So we're going to see how that's going to impact our application given this thing. So we go into our experiment. This is the Key Vault one. We kick it off. See the little thing he's running. we can drill in, and obviously this is a really trivial one, but a bit like what Dan was showing with the logic apps. We could show where it was up to in all the steps, and we can drill in and see where it's up to. So at the start of the test, so we're running the test now, and if we go to the website, this is what we see. So it's still pulling back the things. And that's because, remember, the way the code was written, it only grabs the key at startup time. So it's already running, it's happy, it's chugging away, it's doing its thing. So what we do, we go in and I kill the pod in Kubernetes. Just go and kill it because I'm only running one copy to make my life easier. I go and kill that pod. Kubernetes going, hey, you're supposed to have one of those pods. Where's the pod? So it goes up, no worries, restarts. That's what Kubernetes does, right? It's an orchestrator. But you can see here the stat. Oh, I don't think I had. Oh, I didn't put a box. There we go. If you look at the status, it restarted it straight away, like within a second. But the status is crash loop backup. So what that's saying is the app tried to do it. It's tried to connect to Key Vault. Now it can't. So it crashed. So what Kubernetes is doing is, okay, it crashed. Give it 10 seconds. It's probably going to be okay. Boom. Tries again. Still failed. Oh, don't worry. It'll probably be okay. Give it, we'll do an exponential backoff, I think, of the strategy. Whatever you've configured in your strategy for the. Anyway, it's going through now. It's sitting there just crashing, backing off, crashing. It's taking longer. And as a result, if we go and refresh our site, it can't get any product information. So we've created that scenario. Eventually, that 5 minutes will pass, the test stops, and it takes a while. That's why I didn't do it live, because each of those backoffs is exponential. So by the time the 5 minutes is ticked over, it's waiting like 5 more minutes before it tries again. But now eventually it's tried again. It's now running, it's got its thing, but you'll see over there, the restart counts 6. So it actually had to sit there and try and restart the container 6 times before it finally got going. So this is where testing things like in Kubernetes, what is your backoff strategy? How do you handle crashes? How do you handle the alerting when that doesn't work? Not only can we test the app, we can figure out all that kind of stuff. And what's the implication of that container or that service not running in Kubernetes? So in Kubernetes, when you build things like health checks, I won't say 9 times out of 10. A lot of times when I go and talk to people, the health check is, hey, can I get a HTTP response from that container? You usually can. But what if that is dependent on a microservice running in another container, which is now in an error state? So we'd want to actually improve that by having that container, instead of when I ask you, are you healthy? You don't just tell me, well, I'm running, the world must be great. I want you to go off and check your dependent services and come and tell me if you're not running. That's what a health check should be. So this kind of gives a really simple way to validate that. Similarly, this is now the other one. This is the AKS one, a little more complex. So we've told it we want to do something about pods. And the way this works is these, because it's an open source product, you just give it a bit like, again, like Dan's. He's linking beautiful. Dan had that JSON payload for his integration messages. Here we passed to this little Chaos Mesh Pod agent a little JSON payload that tells it what we want it to do. So in this particular case, we want it to do a pod failure. So actually go and put a pod in a failed state. I want you to do it for 3 seconds at a time in the default namespace, and then the label selectors. Anyone who's done the wonderful YAML that is Kubernetes. Again, all the workloads, you have tags and these different things you can select off. So in our case, it's the Contoso Traders product. If anything, any pod has that tag on it, it'll go and do this to it. So that'll run through. So the overall test is going to run for 5 minutes, but it's going to be turning these pods on and off every 3 seconds, creating a little bit of chaos. And again, same thing, we just pick our target users. And off it goes. And then it'll tell you as it's running, it'll tell you, for example, if there's a failed target. So if there's something you told it to connect to, but it didn't have permission or whatever. So not that the actual test is running and causing failures, but I couldn't get to it. I thought I could get to it. I can't get to it. Particularly with like dynamic tags and things like that might lead to some weird situations. And then which ones are running, and you can drill in and see all those kind of things. So they're kind of the building blocks of building out a chaos experiment. And you can go into the portal there. We can click run. We can do it all manually, like all good ClickOps. But really what we want to do is start thinking about how do we actually build that into our development process? How do we want to build that into our life cycle? And as I said before, the interesting thing is when you start to think about combining these. So yes, we could run a nightly build to run our Chaos Studio and all those kind of things. But what about something like this, where, okay, our pipeline might be, okay, let's go and do a stress test. Let's go and, throw some load at it using something like, I don't know, Azure Load Test, a really good option. So because what we're doing there is saying, okay, how does the system perform when everything's good? Well, as good as it gets, maybe. And then the next time, okay, now let's go and repeat that stress test, and we're going to run this chaos testing at the same time. Okay, we're going to run that for maybe 15 minutes, and then we're going to run the stress test again at the end to see, hey, did the chaos test actually break something? Did something stay broken after the chaos test run? Because that's what happened to me when I was doing my testing on a super small node. Once it got into the space, it just didn't have enough on my, what was it, a B2, this big machine. So it was interesting. There was possibility that even once the test is over, depending on how those components are operating, you can think of that simple example with the backoff strategy. There's a max number of times to retry. So if we hit that max number, then it's going to stop retrying. So when you recover and the service is available, it doesn't go in and retry. So we might need to tweak those kind of policies. So this is the one for the app I deployed. So you can see in this particular case, it actually provisions a whole new environment, provision step. It then runs some Playwright UI tests using Azure. What do you call it? Playwright? I think it's just called Playwright, isn't it? Not Azure Playwright because it's an open source. Anyway, so it runs a whole lot of UI tests across the website. So it has those wonderful statements like, I should be able to get this and add to a cart. I should be able to do this, and it tests the UI before we do anything. So because we don't want to kind of blame the performance test or the chaos test if it was already broken before we even did anything. So we test those things, and then we do that first, and then in parallel, we go and do some load testing, we do some chaos testing, and we do some internal and external testing, all in parallel. And then we can go and see when that's running, we can go and see, I did this in GitHub Actions, but the sample repo also has the pipelines for Azure DevOps, which we're using, doesn't really matter, but you could recreate in any other tool. You can actually go through and drill in and see all the steps and all the load tests and all the kind of things. So once the load test is done, you can go to the Azure load test that's involved. You can see all the requests, what the performance was, all those kind of things. So went really fast, but so I guess wrapping it up, as I said, my experience, it's a little bit like load testing is the way I think of it. Most of the load testing was a one-off thing. You did it to go to production, and that was generally it, right? Unless there was some major change. Whereas, in reality, it would be great to have that sort of thing on a current thing. And chaos engineering is the same. The other interesting thing, as we're kind of starting to think about this, is who should care about chaos engineering? Right? Well, if we come back to what it's designed to do, it's designed to improve the reliability of our apps. So that means then the answer should be everyone, from developers, QA, operations, all the way through. Because sometimes, like if we think of our key vault example, we lost the key vault while the key vault was gone. We couldn't divide them in products. That might actually be the best we can do, right? Other than maybe putting up a more useful error. But what we might want to do is, hey, are we actually alerting on it? Do our operations team understand that's what's happening and that it's okay? Okay might be a strong word. It isn't the end of the world, as opposed to some very critical process where the second it goes down, we should be doing alerts and doing all sorts of things. Through those areas, and particularly putting on my architecture hat again, obviously. Wonderful architects who design these things to give us this resilience on paper, actually validating and closing that loop to make sure it is actually doing what we say. So simplifying that down, I guess we can think of this as in terms of shifting left and shifting right. So if we want to shift left, so earlier in the process, this is really good for knowing before we get to the place where people are going to yell at us a lot. But it's also about, hey, how do we really prove that, that release pipeline, There might be other scenarios like, hey, we've got new hardware in line, or in Azure, it might be a new service. Because we think of all the things that change in that shared responsibility model. Yeah, there's our app and our app code changes, but Azure services change too, right? They've got new features, new versions of the APIs. Maybe I counted it this week. Maybe if there's a new version of the API and it's still got the same parameters, but it's got a different default, right? So if you don't specify something, it now does this. Whereas previously, if you don't do something, it does this, right? So things like that can be uncovered. And you get to start find these weird interconnectedness between things. So that's stuff we can do left. And where maybe it gets really, really handy is when we shift right, building confidence that we do actually, recover, whether that's locally or multi-region. And this is the other interesting one that talks there about the past incident regression testing. So when something goes wrong in production, I'm sure we've never had that, and a root cause analysis or whatever comes out and we fixed it, what do? We usually breathe a sigh of relief and go to the pub. What if we could then introduce that scenario or that combination of events into our chaos testing, so that from then on it effectively becomes a regression test. From then on, go, hey, that one-off thing that we thought would never happen again, it happened again. We forgot to renew the certificates on the storage units. No, we never done. So that's what you can get for that loop. So fix Clippy up. So I hope that was useful. There is I'll share these slides again. There is that repo, which is really good to go and get going with. There's plenty of testing, but I've also created a bit of a playlist on YouTube because I've been watching through a lot of talks in the last little while about this. So there's a collection there about 8 or 9, and it's kind of goes from intro stuff. But there's some really interesting things in there, talking to some of the distinguished Microsoft engineers, I think they're still called, so like Uli and these guys, where they go into it a lot, but they spend a lot of time talking about the culture that goes with this, because it's a bit like DevOps, right? This is awesome, this is tooling, but for example, they call that, one of the critical things to adopting this kind of approach is you've got to have a no blame culture. It can't be someone's fault when you find something. Like, you want to find things, you want to encourage people and reward people for finding problems. So that whole cultural transformation. So there's some really good stuff there, as well as some demos and some Scott Hanselman learn it all in 5 minutes type sessions. So I didn't ask any questions. So who's got a question?
Is there a GUI, like a block programming similar to the Azure integration services, and is there a Copilot for it?
Yeah, so that's an excellent question.
Thank you.
You get to choose. No, you don't get to. You get to choose. All right, that's an excellent question. So all of the ones I showed in that repo are all deployed. That's the other thing I didn't mention. It's a fantastic question. So all of those things, like the experiment and the steps and the test, they're all Azure resources, right? So they all have an ARM template and bicep and all those things. So you can define them. And in this case, all of that was deployed from my pipeline from code. But you can go into the GUI, just like I was doing there, just like you can in Logic Apps, and like that experiment and go add a step, add a thing, tick the box, You can do all of that as well. Click on. Which it makes it really easy to get started with. And if you go onto the Microsoft Learn site, it takes you through some really simple ones like spin up a VM, and then go and do a whole lot of terrible things to it, which it does through ClickOps. But if you look at the repo, it's pretty the bicep and an ARM and everything's pretty straightforward. Awesome. I have one more thing.
Would anybody like me to have that thing?
No, that's a question. It's not a good question. You were thinking about it. Come on.
In terms of implementation of any chaos solution, how would it be?
That's a good question, because I absolutely forgot to mention that. So there's two costs. Obviously, the cost of the resources, and Chaos Studio actually does cost money. There's a pricing for it. It's not very. So the Chaos Studio, there is a pricing for it, and it's based on how long it's running. And it's not very much, because effectively what it is, it's something, there's behind the scenes, you can imagine, there's some compute, there's like, I'm not going to say it's a Logic app, but there's a workflow there, right, that's executing those steps. So what you're effectively paying for is, I'm assuming, it's Todd's version, but you can imagine it needs to store that information, that state, where it's up to, all that stuff, and then it needs to execute those steps. So you can go into that as your calculator, but it's basically like per minute it's running or whatever. It's like 0.00 cents. But that won't be the main. The main cost will be the resources that you're running. But if you look at it like that in a pipeline where you spin it up, test it, and close it down, it's not necessarily running for very long. It's dependent on your environment.
Like when you're changing, for example, the CPU, or you increase the CPU or the network, does it cost something?
Yeah, and that's why I think at one point I said the word simulate, and I immediately stopped myself. And it's really important to understand that when you say increase the CPU or whatever, it's really doing that. So increasing the CPU is not going to cost you any more money, right? But if that triggers a scaling action in your cluster, then that extra node or that whatever. So it depends on what your environment is, right? But yeah, so the actual action itself won't cost money necessarily, but yeah, it could lead to something that would cost money. And again, another reason you have those, you have to explicitly enable resources to be able to be used. Sorry, okay.
Yeah, that's right.
No, you're first.
So if you target all the nodes, I mean, all the pods, does it kill all of them simultaneously or just one by one?
Sorry, so if you turn off all the pods.
If you target,
Yes.
does it kill all of them at once or just one time?
That's a good point. It's actually, I think it's a parameter in that little bit of JSON spec. That in that scenario, that's controlled by Chaos Mesh, and it has parameters you can define a bit.
Yeah.
A bit like if you imagine Dan's demo where he said control the parallelism and it was like from one to whatever. There are parameters to control how many of them you hit at a time and things like that.
And how does
So the Chaos Studio is just orchestrating the overall process. In that case, that particular managing that is done by Chaos Mesh, which was those pods I showed that are running inside the cluster. It's their job to look after that and control that.
Generally on Earth, by default, it doesn't have access to kill stuff in Azure, so you can't.
It doesn't have any access to stuff.
You mentioned that it had to be approved by with the appropriate permission.
Well, there's a specific permission, like in the Azure RBAC model. You know how there's create, distribute, deploy. There is one. There's a specific permission for opt-in to, or it's not opt-in. Enable. I don't know what's called, but effectively enables this resource for Azure Chaos Studio. So by default, I think it's only. I won't guess. Let's say, for example, it's only in the owner role by default, but you can like take that role out. You could take that permission out through a policy even and say, hey, only our test leads can do that in this environment, and maybe no one can do it in prod and whatever it is. It's a
specific to each resource, not each resource type. So in your
yeah. I mean, you usually wrap it up in a policy, right? You don't want to be doing that for per resource, but yes.
Or
or this type of resource in this resource, whatever it happens to be. Yeah.
And you didn't touch on it, but the process injection, is it doing something like a just injection into code?
The faulted for the application one? Yeah, I honestly don't know. So I haven't looked at that yet. So there's two things. One is the thing that's in preview, and I haven't looked at it yet. It's built into the SDKs, and I don't know what it is. I need to go and look at that. That's next on my list.
That's right.
But there's also some other stuff, and I didn't get into the detail, but there's some Microsoft research is actually working on some other things which are more not Azure related. So like just like we had the Chaos Mesh for Kubernetes, which we've used in AKS. And the Azure specific stuff is in the Azure SDKs. What about more generally? What about in a .NET app, or a C# or a Node or whatever app? They're working on some stuff to come up with the way I read it was like kind of a cross-platform library, because a lot of these languages have all sorts of frameworks, but they're all different. So what looks to me like they're doing is they're trying to come out with some kind of cross-platform library for injecting faults at an app code level, but it was a bit vague and researchy.
I've seen something like Dynatrace that does the injects for logging alerts and
Oh, okay.
yes, so I thought it might have been cooked into the JIT. It had some things. That's right.
I don't know. I haven't looked under the hood. It's in the SDKs now, so in theory, we should be able to go and look at the code in
Not a
it's
big
open
deal.
source. But yeah, no, I don't know. Sorry, someone else. No, here.
Mister, if you're running that in the pipeline, you can define your chaos tests as code.
Yes, and all the ones I did there they're in that repo. Yeah, so that's the saying. They're just each part of that chaos test is an Azure resource, just like a storage account. You know, an experiment is an Azure storage object at the API level.
Fine, available in Bicep.
Yes. Waiting for someone to. Oh, there you go. I said I'm just waiting for someone to ask me about Terraform. I don't know about Terraform.
Oh.
We can't control it.
Say that API supports anything that Bicep does, but
Yeah.
some people say it's also not built.
It'll come. It's just when they get there.
When they do provide it.
Yeah.
I used to work in automation testing, and usually like I develop my steps, and if all the steps were successful, like everything is okay. But what about in here in chaos? Like you try to break things. Basically,
You're not trying to break things. What you're trying to do is see how the system responds to a fault.
so that's my question in here. Like, how do you see the results? Like, do you have a summary right at the end? Or
Oh yeah. So yeah, it generates and I didn't get time to, but yeah, there's a couple of different lenses on it. But yes, the summary of the. Oh, in fact, let me. Oh no, they're succeeding at the moment, so it's not working. But yeah, when you go in, a bit like with the Logic app, you can drill in and it stores the state of the unit tests and things like that. But actually, in the pipeline, yeah, that's probably hard to show. But yeah, in my GitHub action, I could go in and I could see they had the full script, and then as I drilled in, like it said, okay, here's the chaos testing. It also appeared in there in the logs. So they're in Azure in the thing, but they're also emitted as logs. So depending on how you there's a whole bunch of ways to surface it. I guess the other interesting thing that I found in doing my testing, because like when that AKS cluster get provisions, it's like vanilla AKS deploy. Now by default, things like alerts don't get configured, right? So as soon as I'd run the test, all of a sudden on my dashboard, on my Azure dashboard, I was getting a thing going, you should go and configure alerts for AKS. And if you go into AKS, there's a thing that says configure recommended alerts. So it's things like that. So there's the app side, but then there's also like an operational side. What is the problems or gaps? And sometimes they get surfaced through Azure Advisor and things like that. So you can get to them that way too.
The chaos team need PS rule.
Everything needs PS rule, doesn't it?
I think that's a very valuable point in terms of like, yes, we're talking about in the context of building an application, but how many, like not all issues that happen in the environment are actually because the developer did something weird, right?
Most of the time, but not
Not all. Like there's plenty of cases where, certificates, DNS, there was a problem with an Azure service, right? How do you test for that? How do you make sure that your application or your infrastructure is built in a way that is able to survive it, or not survive it, but at least you know about it?
Mm. And particularly those ones like where it's an underlying service as opposed to the front service fails. The front service, the developers go, oh yeah, it's that. But when it's a backing service, it's a middle tier service that's talking to a key vault in the storage. How does your instrumentation and your monitoring actually surface that in a useful way? You can actually understand the problem.
I was going both directions. But how are you defining a pass or a fail for a pipeline of this?
Well, yeah. And the same thing, right? The chaos experiment, as long as it can talk to the things it did, it always succeeds, right? Because really, the pipeline though might fail if a step couldn't run the load test UI. But you're right, because it's trickier, because what it's not necessarily failures, although we can go to load testing, we can go to we had the Playwright UI test, so we can test functionally. But a failure might not be that the app still works. The app might be, oh, we didn't give the right discount to the user because we didn't get to this service. It can be a little more nuanced than that, right?
Don't say path fail, say this is acceptable to go to the next stable environment.
Correct. Well, and think again too, back to that little diagram-y thing of that cycle. That's why I put that up, right? It's the hypothesis. Here's what we think is going to happen. Whether that's good, bad, or indifferent might not be relevant, right? The question is, do we understand how our system performed, and are we okay with that? Because it'll come down to that. It's not going to be a pass fail, I don't think. Individual bits will be, but if hey, because you can think there might be a thing, well, hey, at the end of this process, something should end up in our SAP environment, and we're not hooking that up to this. So there's going to be a step. Someone's going to have to go and look in SAP. But yeah, I think it's more nuanced in terms of what do we want to happen? Did that happen? Did it recover? Did it give the right error message? Did it take an alternative path, which is maybe not ideal, but it keeps going? Or did it fail? And really, we're expecting it to fail, and it failed. And as long as the right alert gets generated, that's actually our success definition, right? So it's very context specific. And that the error that got the notification that got generated went to the right person and actually provided the context they needed to deal with, as opposed to something went wrong, which is what they often get. Or, hey, the system's down. Well, no, it's not, but this part's down. So, yeah. And I think that's also where that cultural part comes in. It's a bit like a lot of things. It's not just, unit test passing or failing. It's, is it working? And working is kind of nebulous. Certainly useful.
And interpreted by the business. So, like, did the customer get the refund?
Which is why remember that part at the very beginning when I said requirements. What do you actually want to happen, other than it being 100% and never ever going wrong?
Oh, that rings a bell.
Yeah. What downtime can you have? 0. What latency do you want? 0. Yeah.
What budget have you got? 0.
Which is why I define requirements in the reliability pillar. Forget chaos engineering. Define your requirements. Cool. Awesome. Thank you. Expected chaos. Long drive home.
I'll see you again.
Sorry. I wear my Kubernetes shirt.
It's just a problem. There's no H there.
It's 100% accurate.
Yes. I'm wearing the Kubernetes, but there's no H.
There's no happiness in Kubernetes.